A pleasant morning to one and all. I'm Dr. Sumitra. Today we are going to discuss about the perceptron algorithm. The perceptron algorithm, a foundational concept in neural network, serves as a bedrock upon which our more complex models are built. Developed by Frank Rotin in 1957, the perceptron represents the simplest form of neural network, capturing the essence of how the individual neuron processes the information. Understanding the perceptron is pivotal in grasping the fundamental principles of neural network architecture and the supervised learning. As its core, the perceptron is a binary classifier for a computational unit that takes a multiple binary input and produces a single binary output. The perceptron architecture mimics the basic structure of a biological neuron with the input acclants to dendrites and processor units comparable to the cell body and an output acknowledgement to axon, and mathematically the perceptron computes a weighted sum of its input and adds a bias term and applies an activation functions to determine the output. Let's deviate into key components of the perceptron algorithm with the input and output. The perceptron receives a multiple binary input denoted as x1, x2 till and xn, and each input is associated with a weight of w1, w2 till wn, reflecting the importance or the strength of its input in influencing the perceptron decision. The weight represents the semantic connections in biological neuron, determining how much impact each input has on overall computation. And the weighted sum, the perceptron calculates a weighted sum of its input and weight using the formula weighted sum is equal to w1 into x1 plus w2 into x2 till wn into xn. This step mirrors the integrations of the signal in a biological neuron where its empathetically strength modulates the incoming signals. Adding the bias, a bias term B is introduced representing an offset that influences the overall decision making process. The bias is acknowledges to the resting membrane potential in biological neuron. The weighted sum and the biases are weight combined. Weighted sum plus B. The activation function, the results of the activated sum and bias is passed through an activation function, typically a step functions or a sigmoid functions in the case of a perceptron. The activation function decides whether the perceptron should fire or not, determining its output. If the result is above in the certain threshold, the perceptron output is either 1, otherwise its output. The perceptron learning process includes adjusting its weight based on the error in its prediction. In the supervised learning setting, where the perceptron is trained on a labelly datasets, the algorithm aims to minimize or the difference between the predicted output and the actual output for each training examples. The learning rules for updating the weights in a perceptron algorithms can be expressed as new weight is equal to old weight plus learning rate into error into input. Here, the learning rate controls the size of the weight updates, preventing overall a large adjustment that could lead to an oscillations or the divergence. The error is a difference between a predicted output and the true output. The perceptron algorithm iteratively adjusts its weight during the training, attempting to find the set of weight that maximize the classification error on the training data. It continues the process until the coverages or the predefined number of iterations. While the perceptron is a powerful concept, it has a limitation, one adaptable constraint in its inability to learn a non-linear decision boundaries. Since a perceptron decision function is linear, it struggles to handle the data sets that are not linearly separatable. This leads to the development of more sophisticated neural network architecture, such as a multi-layer perceptron, which can learn a complex non-linear relationship through the use of hidden layers and the non-linear activation function. The perceptron significance extends beyond its individual capacity as a binary classifier. The neural network serves as a building block for more advanced architecture. The multilayer perceptron is also known as a feed-forward neural network, stack multiple perceptrons in layer, enabling the models of an introduct pattern and the relationship in data. I hope you are clear with this perceptron training learning rules. Thank you.